Ready to go? Cool. And we're off. Welcome everyone. Also welcome Alistair, who's joining us remote, to this panel on the future of the modern data stack. So very much looking forward to discuss this in the round for the next 40 minutes or so. I wanted to give us, just to get us all on the same page, it's sort of a bit of a primer on what the modern data stack actually is. I mean, at least to me, it's described by, well, several principles. It's modularity, not being stuck in a single suit, but actually in a single software, but actually applying sort of more of a best of breed approach for storing, modeling, visualizing, sourcing data, and so on. It really takes a lot from software engineering best practices that are well established in the IT sector and are now slowly moving over to the data stack, which I think we're all really happy about. Really increases the productivity and the output of many data teams, also of the ones in our ventures, of course. And I mean, it centers to some extent around SQL. We'll talk about how much that actually is the case. And there's been a lot that has happened. I mean, probably since the launch of Redshift back in 2011, there's sort of been, I think DBT calls it a Cambrian explosion of relevant tooling in the space. All of that is well established now and is being picked up by basically all of our ventures. The question to us really is, well, what are the next trends to sort of bet on? What are the next trends that maybe our investment team is also very interested in and looking at? So very cool that 3 of our founders directly in that space are joining us today. And I want to start off with a quick round of introductions. So I want to start with you, Martin. Basically just telling a bit about who you are and what you're building.
Yes, thank you. I'm Martin, co-founder in Alvin. And my background has been in data engineering and very much on the technical side of it, working with actually building data products and kind of dealing with people on the other side, the consumers of these data products, and really kind of dealing with issues there. And a lot of this is kind of what is the background and context of Alvin. And what we strongly believe is that like understanding data usage and lineage is like a core thing for the modern data stack. So essentially what we're building is automated, on the technical side, it's automated data lineage for warehouses and reporting tools like BigQuery and then Looker on the other side. And then we do analytics on top of that to get insight into how your analytics is being used and performing.
Very exciting. Cool. Mike, how about you? Welcome.
Thanks, Ole. I'm Mike Rossum. I'm the CEO and co-founder of Quix AI. It's a stream processing platform founded out of the experience that me and my co-founders had whilst working in McLaren Technology Group. That's in McLaren Racing and McLaren Applied Technologies. We were working on systems there that were transporting telemetry data from the cars to the factory to help the data engineers build real-time processing, real-time simulation, real-time machine learning, really to help them win on the track. And we found just so many difficult problems there, but also through my role, I was head of innovation. I was trying to commercialize these technologies in other industries, working with train operators, airlines, airports, even in healthcare. It's really, really hard actually to build the streaming systems, but even more hard for a developer who's used to working with a database-centric approach to actually work in a pub-sub approach using a broker. And so that's what we're here to solve. We're building a very low latency stream processing platform. It's at the intersection of Kafka and Kubernetes.
Okay.
And we have our own client library, which makes it really easy for Python developers at the moment, and C# developers as well to write pub-sub models in really simple language, whilst getting the benefit of the horizontal scale and resiliency of those two modern technologies.
Very powerful. Nice. I want to continue with our next founder, which is Alistair. So thanks for joining as well. Maybe you can introduce yourself and tell us a bit about Gigapipe.
Oh, it's a shame that I'm not on site, actually. I regret this decision now. But yeah, basically, so I'm Alistair, the CEO and co-founder of Gigapipe. My background is quite specifically in high-performance distributed applications and database infrastructure. And while I was working in Berlin, actually, while building a kind of brand new ad server as a chief technology officer, it became very clear that actually reading and writing lots of data at a really, really high volume, such like billions of rows of data, is extremely difficult and is very hard to do in a cost-efficient way. So I decided to build Gigapipe in order to enable companies to read and write data at really, really large volumes, like terabytes of data a day, without having to hire an entire engineering team or understand the really high level of complexity involved in big data systems. And Gigapipe essentially offers you that big data infrastructure without the necessity to, hire an entire engineering team or pay an enormous amount of money, where you're not then really able to focus so much on your primary business model, but instead are very distracted in how to store this data that is actually useful for you.
All right, cool. Thanks for the little primer. Very exciting as well. We're also joined today by Leo from our investment team. So curious to hear more about you and about why, the topic of data, to my excitement, has really been in our focus from the investment side at Project A lately.
Yeah, thanks, Ole. I mean, much less impressive and cool than our other guests. Just working in the investment team, unfortunately not building cool technology, but fortunate enough to work with these cool companies and startups and founders as an investment manager. So basically working in the investment team. Yeah, and I mean, recently we've been looking a lot into developer tooling, data infrastructure, data tooling. And I mean, it's probably a bit of a VC narrative. Hopefully I don't bore anyone with it, but I mean, if you look at like 10 years ago, Mark Andreessen wrote this big piece about why software is eating the world. And I mean, I think if we look back, pretty much most of the claims were right, essentially. And yeah, I mean, we fundamentally believe that also in the future, data companies data-driven companies will be successful companies. And any company that wants to differentiate as a technology-driven business will need to leverage data to create differentiated user experiences and to drive also operational excellence and squeeze out the last margins. I mean, spaces are becoming so competitive. And I mean, if you look at large technology companies like TikTok, Amazon, Netflix, like they all leverage data to an extent to exactly do that, and you can exactly see them outperforming their peers. And it's still incredibly difficult to set up these systems. And I mean, most of the tooling in these companies is custom built, right? And there are no tools and products on the market. And I really believe we're still in the early days of like any company getting access to these tools and also becoming more data driven. But yeah, curious, of course, to hear what everyone else thinks.
Yeah, of course. I mean, for the reminder of the session, so for the remaining 30 minutes, what I was basically planning to do is throw some trends and hypotheses that Leo has seen, that I've seen in my day-to-day work working with our portfolio companies, and just really want to hear your take on. So what we've seen through these introductions is that, handling sheer data volume seems to still be an issue, but also the inherent complexity once you integrated all your data into a single place, that also seems to still be an issue. And I want to start off with this trend or this ongoing discussion around batch and streaming, so to say. So we've recently been talking, Mike, and you said the data warehouse is where data goes to die. And if I think about the structures that my team is building, it's still very much batch-based, and it still caters to most of the use cases. But that might not be the case much longer if we don't just want to do reporting, but we want to actually impact, like the companies that you mentioned, the growth curve. So where does that come from, the data warehouses where data goes to die, and what do you think companies can do better, basically?
Yeah, I mean, that's quite a strong statement, but ultimately that comes from our experience in McLaren. We found that a database of any shape or format is just in the way of live data processing. If you have to do a read-write operation on a DB to then process it and move it on towards the end consumer, you're adding latency and cost. There's just fundamental compute resources and time required to write from compute through memory to disk, even if it is a solid-state disk, and then pull it back out through that stack and serve it into, a compute engine, not your database compute, but your CPU or your GPU to serve a model and inference. It's just a long journey, and it's just an expensive journey. So the realization of McLaren as well, we've just got to get the database out of the way, and how are we going to do that? The approach was Kafka and message brokers. Other brokers are available, what we see is that a lot of companies are investing huge sums of money in data lakes. This term dump, I'm just going to dump my data. It's such a casual term in the data industry. I'm just going to dump it in a lake. Someone else's problem. What that means is, again, we speak to leaders of data analytics teams, and their engineers are spending a lot of time sifting through the lake, fishing for the insight. And then the end consumer ends up being a report for an exec going into a meeting. And I'm guilty because I have to do board meetings and I ask my data engineers for, I need a report. But that seems to be, in a lot of organizations, unfortunately, state of the art. And what you're seeing with the startups that are eating the world based on software, they can't build their companies without data. Mm-hmm. And so the next generation of value is really being created by the companies that build data products and not data dashboards. And so that's where the strong opinion comes from. You need a processing layer before your data gets to the lake or the warehouse. I think there's equally valid use cases, lots of really good valid use cases for still having the warehouse. But our position is you need a processing layer before the data arrives.
Cool, very interesting. I think that works really well with Alistair or segueing into Gigapipe, because you truly very much believe in the concept of a database as long as it's low latency, high performance, and so on. So basically contrasting to what Mike just has been saying, Alistair, what do you think is the place of the analytical database moving forward for your customers, or also just in general, and what's it going to be used for?
I mean, the thing here, sort of in my opinion, is that, I'm not against stream processing per se. I think it has a very, very valid use case. I just don't necessarily think that all data goes to die per se. I think that you could actually combine both to achieve two different goals, and even within the same company, right? So you could have like some data that gets loaded and will actually get stored on a more kind of permanent basis that can then be used for retroactive reporting on much larger data sets, or power machine learning models that need access to a lot more information over time and that can't be updated sort of live. Or if there are like requirements for, like really high memory usage, I imagine stream processing uses like a lot more memory, for example, which can then become an issue surrounding cost. So I just think that, it really depends on what you're trying to do. What we focus on at Gigapipe is enabling you to be able to store that data, but also be able to get that data out extremely quickly. So leveraging features that come directly from ClickHouse, such as materialized views, mean that you're essentially, in a way, you're almost stream processing, because these views are live updated when rows get inserted into the database, and they don't actually they're already pre-computed, so they don't actually need to go back and query the database anymore. It might slow down the ingest rate slightly, but it's pretty insignificant considering how much data you can put into ClickHouse and Gigapipe. As you can achieve a very similar effect, but you also get that kind of permanent storage layer if you want to then, change your queries or do something else. Because something I would see as an issue, for example, with these new companies that want to, they want to leverage their data and they're going to be very data centric. Say, for example, you're doing the stream processing, everything is going great, but now you want a new query. It's, you don't have as much access to any historical data, so you kind of have to start all over again to some degree. Unless I misunderstand sort of that concept, as in, you wouldn't really, you'd have, exactly, like have to start again almost to a degree with the new data coming in. But that's why I honestly believe that using both of them in parallel would be like the most optimal solution for things. Stream processing would power reports and provide information to data engineers on one particular thing, and the permanent storage layer would be able to provide information on other things. It's very context dependent, I would say.
Yes, very context dependent. I really like that. Really depends on the use case, and that's what we have learned at Project A recently. It really always starts with the use case and not with like, this technology is exciting, we should be using it, let's figure out for what later on, but really always starting from the context. Thanks a lot. Now, of course, handling data volume, no matter in which way, is one issue. But now with all these emerging technologies, I feel like one challenge that our companies recently have is just handling the complexity within their data. And that's where data governance can come in, hopefully. So I know we've been chatting about a lot of tools in this space. Leo, why do you think it's finally time for data governance to shine?
Yeah, I mean, again, if you look at the broader perspective, right, we come, I don't know, like 5 to 10 years ago, you know, we were occupied with just sending data from the edge to some centralized place, cloud data warehouses. Now actually like abstract away all that heavy lifting, you know, that you needed to do on premise. So now basically you end up with much more data sets and much more complex data pipelines. And I think now is actually the age where also non-technical users, right, like increasingly are hungry for data, want to have some kind of self-service access. I mean, not throwing in more buzzwords here, but yeah, and I think that's exactly why it has become super important to actually understand how data is being produced in my environment, and to also give that access to people that don't want to or don't need to read code for that. And yeah, I mean, Martin, maybe, I mean, you're the expert here in the round. Maybe you could provide some convincing arguments why now is the time actually for data governance and metadata management.
Yeah, I mean, I think it kind of has always been the time for it, but I think, as I said, now we're in the time where actually more and more companies realize that we actually need to use the data. We can't just stick it there and kind of not use it. Competitors are kind of squeezing the margins. We really kind of need to do this to keep going. And so then there are there's a big spectrum. I guess you have the GDPR, like the compliance issues of working with data, security. And I think the biggest issue we see is basically that it's kind of like you say, data goes there to die. So many data sets, so many tables. What are they actually being used for? What are the kind of definitions that we have metrics, we have reporting, we have like 10 different dashboards that are called the same. And that's really kind of what we see in Alvin and what we're trying to solve, to just basically, one metaphor that we have been using is that you have like a webmaster that uses Google Analytics to see, okay, what are the dead links on our kind of website, what are the most like visited and like the hotspots on our site, and to some extent that's like a very simple metaphor for how we think in Alvin about, you know, you should be able to do this with your data infrastructure as well, to really understand, you know, where are the pain points, where are the issues, where are the places where people hit the broken links and like drop off and are upset.
There's one thing that I don't understand though, so maybe you can help me. We've been talking about the data warehouse, for example, not being any longer just like the reporting dead end, but suddenly we have like cool data products that we can empower. So we can write, I don't know, recommendation engines, personalization, experimentation platforms. Like it seems like the overall pipeline gets a bit more complex. Yeah. And then, so one use case that my team starts focusing on now more is called reverse ETL, or sometimes called operation analytics, like moving data back from the warehouse into different tools. Is that, I mean, that must be a lineage nightmare, because you can maybe still see how data is modeled in the data warehouse, but what it does once it hits other tools again is really, really hard to track, no?
Yeah, it's a very good question, and there's definitely, like you say, depending on where you kind of have your integration points. If you look at, for instance, Snowflake, it's a good example where it's like very SQL oriented, so you have like a very good insight into like, is data coming from S3 to S3, whatnot. But in this case, you still have this like system boundaries where you kind of lack the observability into where it's coming from and where it's going. And our thinking there is a lot of standardization, and what you would use there is typically something like Prefect or Airflow to orchestrate that. And that's kind of what we see where we're going, where as long as you kind of cover like this orchestration as well, then you get additional metadata. You know, example in Airflow, you have like these operators that you can use to say, okay, this operator is actually the one responsible for taking data from Snowflake to S3, and then from S3 in some job back to Salesforce or something like that.
Okay.
So it's kind of all about the context, really. And yes, as you say, it is super complex, but that's really what we are trying to solve now, and just taking all of this complexity away and give like a very clean, in all essence, we're really building a data set about your data that you can use to understand a lot of things about it.
Yeah, I think taking that complexity away. I mean, that is something, I think, a common theme also across all three of you, right? I mean, I guess it's all kind of managed service, cloud first products. But I mean, I know also from conversations that still sometimes, potential customer discussions go very much into an on-premise direction. So, I mean, where do you see this going? Like, I mean, how deliberate is the choice basically not to do it, or do you basically also see yourselves like going into more of an on-premise direction? Like, is on-premise dead?
Not at all.
Definitely not yet.
We see, yes, sir.
Go ahead, Alistair.
I was going to say, in terms of requests, we have like half and half at the moment, I would say. Like half the people are interested in on-premise and half are interested in the cloud. On-premise, typically, those people are interested in security and being able to control their own infrastructure, or they have very strict rules and regulations. So we're talking like banking and finance, those kind of industries. However, I would generally say, though, that cloud will eventually win over on-premise. I don't think that the future is going to be continuing with on-premise, or that it's necessarily going to grow too much. I would say people are going to become more and more comfortable with having their data reside within, these other companies that are actually experts at doing this kind of like data management based solutions. It might take a little while to get there. There's a lot of like compliance things to go through, as was mentioned actually before by GDPR. That kind of thing as well that has to be dealt with, but yeah.
We see the same. There's a lot of use cases, especially when you're in the higher volumes and velocity of data. These are the bigger companies, and they've got stricter requirements around what they can actually do with their data. So we're seeing early adopters, startups and scale-ups might use the cloud because they're pretty, focused on build and grow. Bigger companies that put more thought, they love the tech, and what they're saying is, we love it, but can we just install it on our own cloud, or can we install it on-prem? There's lots of great use cases for us where it could even be, national security. Talk about a company like Rolls-Royce engines, airplane engines. It's also kind of can borderline on military applications. They want it on physical prem, like proper our own servers in our own facilities.
Would that be to do something like predictive maintenance, and that's like too crucial?
Yeah, every plane in the sky is sending data to Rolls-Royce. They actually bill by the hour of flight.
Okay.
Not many people know that, but that's how they bill the Boeing and Airbus. They're billing by the hour of flight, but they're also doing predictive maintenance and looking for other signals that there's potential failure modes. But they are just give it to me on-prem. And then you might go to a financial institution and they're more cloud friendly, but they say, give it to me in my private cloud. So it's just a huge amount of deployment options. And then finally, what we've been seeing, the biggest organizations actually start reverting away from cloud to private servers again, because the cloud becomes too expensive at some point. And I think if you read in the tech news, you're seeing some of the Airbnb, for example, migrating off of the public clouds into their own data centers, a lot like Facebook and Google, started out with. So you're seeing that kind of full life cycle. Might be start on the cloud, go scale on the cloud, then move to your own data center. It's very interesting, and having the tooling which you can port across the environments, I think, is increasingly important for the future of the data stack.
I mean, this concept of repatriation and moving back into your own data centers, something that even Andreessen Horowitz has been talking about a lot. I think most of our ventures are not at this scale yet, but even they face like over like €1 million builds for their analytical database per year, which is like, I mean, you start thinking about that at some point. Another concept that I would be really curious to hear your thoughts on, and disclaimer, I'm highly skeptical, is the data mesh. And I want to start with you, Alistair. So the data mesh seems to be a concept where you have like decentralized data warehouses maybe, or analytical databases. So do you actually see one of your potential clients maybe deploying 10 little gigapipes around their company, for example?
I mean, deploying lots of different little gigapipes, I wouldn't say would be super necessary. Gigapipes specifically, you'd use R-based access controls, right? So you would just have an account with Gigapipe, and you might be able to create like a team, for example, that has its own access to its own clusters, its own regions, and they follow their own particular guidelines. I'm a big fan of decentralization in general, but I also like things being in one place where I can observe what's going on very easily. Contextually, this is why, in Gigapipe, your access to, clusters across different regions is very clear to you, and why we're also building an ecosystem around our core ClickHouse service, because what we want to offer people is the ability to create an entire big data infrastructure system, but without having so many different vendors and so many different components in different places. The applications might be separate. We don't build Red Panda. We work with Red Panda for them to do that. That's what they do best. Same with our other technology partners as well. But what Gigapipe does is it enables you to have those individual applications, but in a singular billing system and in a singular place to control everything in the way in which you want. Further down, this can then be segregated by team, department, however you decide to configure your own roles, for example. So, you could conceptually call them little gigapipes. Maybe we can call the team a gigapipe.
Okay.
But yeah.
Thoughts from Martin or you, Mike, on the data mesh?
It sounds like, from what my definition of it would be something like microservices for data, where kind of you have owners and documentation, and it's kind of a bit unclear to me what is like the big benefit, I guess, because if you have microservices, you have to maintain the API like surface and the implementation, but in many ways data is a database. It has columns, so it just the benefit from my perspective just doesn't seem to be like huge. Okay. Of doing it in this way, versus just having it in one place. But
data is a database until it's streaming data.
Exactly.
And in that case, so you do see some use cases. If you want low latency, we can do a round trip between here and France in 60 milliseconds or something, as faster than the human can really perceive. But if you were to have that data center in America, then that would probably be 300 milliseconds. You might start to actually have a problem. And not only that, but you're transferring data across international boundaries. Okay. So you can see some use case for decentralization, a very much use case specific. Again, it's like right technology for the right application.
But just doing it for doing it, it's kind of like Michael says. It's, in certain cases you have to do it if it's GDPR or privacy. You need to mask data so that certain people in a company can't access it for other regions, etc. And that's already being done. But just adopting data mesh, I don't really see the huge appeal in.
Yeah.
There's no data mesh players that we're currently looking at. You wouldn't be able to tell, of course.
It's all confidential, of course. No, there were definitely some, but I think in general there's a lot of confusion around the concept. The more I read about it, the more confused I get.
Maybe I'm completely mistaken, and I will get angry comments now on my views on it.
I would ask,
I would add to that. Yeah.
What's a data mesh which isn't? Is it just having a Quix instance in each region that you operate, or is it something more complex than that?
I think where it comes from is that companies are increasingly frustrated with returns from their data infrastructure,
right?
Because it's very slow and requests take really long to actually lead to any reports, analyses, whatever.
Right.
And their approach then, because of the data mesh, is okay, let's decentralize. The salespeople own their data, the product people own their data, and then they sort of offer curated data sets to the entire business, and you can just start matching and merging.
This is where I just get confused, because the reason why you have a data warehouse is you want to join all the data across all dimensions. Exactly. So it's this fundamental mismatch in my kind of view on why you want to do it, because it kind of goes against the idea of actually being able to slice and dice the data in the company.
Yeah. And the only thing that I would be excited about is from this decentralization and moving closer to data producers is that they might finally start caring about data quality. Because so far it's always been the core data team running behind everyone and noticing, unfortunately, last when a schema has changed and all of their reports or whatever suddenly don't work any longer.
I think you hit on an interesting point there, that the business is suffering from lack of ROI. If you've got no return on investment, then you get frustrated, but I don't think you need a data mesh to solve that problem. You actually need to think about what the data means for you and your organization. You need to invest more in the application layer, which is designers to build great user experiences and product features and product owners, and probably data science and analysts to turn the data into data products. What you see at the moment, the top tier data organizations, data leaders, they have huge teams. There's a food company in the UK, Just Eat, 200 data engineers. Now how much investment is just going into the pushing and shoving of data between databases, and how much is going into the product and application layer?
And creating real value.
Creating value on top of the data. Data's worth zero. It's actually a cost center for most organizations. Figure out how to create value.
No, I was going to say, plus there are also like, better solutions that you could probably approach. Say you're suffering specifically from this, what we were discussing earlier, you've got one team who needs data from like France, another from the US, and then, if the database is in one location, that's just like a problem. But, there are good solutions to doing that, such as having like multiple replicas and being able to structure the data in a way that most often query data comes from one team, likely. You can set that data in one place, and you can use even replication so that generally speaking, your queries are going to come from whoever needs it most. The likelihood that you can structure data very well is pretty high, and it's going to cost a lot less than trying to create lots of different infrastructure services that have like their own different machines, they're like their own cost associations, and making a very sort of complicated and confusing setup. The database itself would be singularly more complex, but I think the complexity would still be lower than the sort of the issue having like lots of different instances of things that have like different configurations and setups.
And Ole, I mean, question to you. I mean, I guess trust is still also one of the main blockers to widespread usage of data in our portfolio, right? And I mean, how do you see in the world of decentralization and self-service, how do you see their basically consistent metrics or, like consistent pipelines?
I mean, we're always preaching for this single source of truth, and it just feels too incredibly hard if you have a decentralized data infrastructure approach to actually maintain it, like in terms of definitions of a customer, what revenue actually entails, and so on. I feel like having that in a single place might be more scalable and also then more accessible to people. I feel like so far everyone has been sort of in their comfort zone, so I'm trying to throw something at you that is a bit more outside, and maybe not even a tooling problem at all, which is, well, basically really cataloging knowledge in a data team, or what is sometimes called tribal knowledge. So what do I mean by that? I feel like in general, the data teams I'm working with do two things. They run through this endless stream of requests. I need this metric in this report broken down by this. And this is super frustrating for them, but they need to just get through this. And then they also do really cool analyses. They do really cool machine learning products. But these are, to a certain extent, unfortunately, not really well documented. So what they simply are not able to do is stand on the shoulder of giants. So they're not building on top of what others have figured out previously. So our ventures segment their customers, like analyze their conversion rate, all of this stuff again and again, and it feels like they're starting from zero. Is that a tooling problem? Is that a cultural problem? I'm very curious to hear, based on maybe not your current positions, but maybe also what have you seen previously. How can just teams improve and start like building on what they've already learned previously?
Way out of the comfort zone, Ole.
Yeah.
Good job.
Way out of the comfort zone, yeah.
Yeah, so from what we see, it's good documentation, but it's good inter-team engineering practice. So good software engineering practice in data engineering. Actually, most my three co-founders came from software background and transformed in McLaren to become data engineers. So reusable code, well-commented code, good documentation. A lot of it's kind of human behavior and good engineering practice, but then the tooling can facilitate that. So if you have a data scientist developing a feature, input variables to output variables in Jupyter, how do you really use that same code in your deployment pipeline when they're two separate worlds? At the moment, you very much see this world of data scientists working over there, fully supported and enabled by a data team, but dragging on resources when they've got other things to be doing. Two different groups of people with different objectives, trying to work together with disparate systems. rewriting code twice, rewriting it in different languages, Python over here, Go and Scala over there. So all of these kind of things you can solve with tooling, but you also just need good engineering discipline in the data organization.
Yeah.
Sure, and a level of communication as well. I mean, we actually distribute our teams not necessarily by their direct function, but what programming language they use. So our teams are actually more distributed by programming language, so that everybody who does like the Python kind of stuff, they're able to share and reuse the same code because they may have worked on the same thing. It doesn't really matter if they're a data scientist or if they're actually an engineer working on the API. Technically, they'll still all sit together. So, you know, that enables a higher level of communication and a much better understanding of the Python code bases, for example, or the Go code bases that we use as well. And so far, this has worked out pretty well for us. We're scaling the team quite a lot at the moment. And because the product is like pretty difficult, you know, the hardest thing is always like, how are we onboarding people? So we have like a central platform, we use Notion, for example, and that seems to work very well. But you know, what was mentioned before about really good documentation, et cetera, is that sometimes that's just really hard to do, because when you create something new, you then have to remember to document it. And, you know, if it doesn't get documented, it kind of then gets out of date and it can become very, very messy. So it would be cool to see something that somehow manages to oblige you to do that a little bit better. But yeah, I mean, I really do agree with
something we're quite focused on building into the product is good CI/CD type practices. So having a dev environment, a staging environment, and prod for your data, and encouraging users to do good unit testing when they're writing their logic, but then being able to run integration tests without really thinking about it. So that they know that when the live data starts flowing, they test it on a replay on historical data. So when the live data starts flowing, they know it's going to work well in production. It's a kind of a McLaren racing philosophy. If you're developing Monday to Friday, you've got to know that stuff's going to work Saturday and Sunday. So we're trying to bring those philosophies into the UX of the tooling to help data engineers actually build more reliable infrastructure, which they can trust and share and grow on top of.
Yeah, we're getting back to the trust topic that you mentioned earlier.
I guess we're running a bit out of time.
Yes, we're running a bit out of time. I feel like we could continue for a couple more trends and hypotheses, and maybe we do so in an upcoming podcast or so. But for now, thanks a lot for joining today. I'm very happy that we've been able to run through some of the trends that are awaiting us when it comes to the future of the modern data stack. Thanks for joining remotely, Alistair, and enjoy the rest of the conference and talk soon.
Thanks, guys.
Thanks for joining, everyone.
Thanks, guys. Have a nice day.